let's take these industries where they have this problem of delivering complex information in context and start applying Watson to it, right? And this is where, again, start visually imagining these Jeopardy boards for healthcare or insurance or retail or geology or whatever you may. And let me speak to you a little bit about how now Watson works and how it does what it does. So the fundamental question is, computing has been around for 50 years now, at least. Why is it so hard for computers to do this? Why is it so hard for computers to take all this unstructured data and process it? The problem is in the way systems are designed. One of the things I say sort of half jokingly is once Watson is commercialized, we'll draw a line in computing and say, before this time, computing was nothing but a giant calculator. Okay? It was all deterministic stuff, it was crunching through data. After Watson, you'll be able to do that, plus you're able to understand the meaning, you're able to create a learning system that understands human language, the semantics and the syntactics of it, and is able to provide information to make better decisions. So here's an example. The question was, where was Einstein born? In traditional systems, unless we have that information stored, as physicist was Einstein and his birthplace was home, that query is pretty brittle for your traditional data warehouses. However, given Watson's capability to understand human language at massive scale and speed through the connections that it makes, it can take a sentence like what you see on the right here and make the deduction that Einstein was actually born in London. Okay? A very powerful thing, and I'll give you a statistic on that. We took Wikipedia when we were playing Jeopardy. It was not connected to the internet, by the way, when we played Jeopardy. They were told it has to be a standalone machine. We took Wikipedia, put that into Watson. It was about 7 gigabytes. By the time Watson got processing through that information and understanding the meaning, it was roughly 44 gigabytes of what it created out of Wikipedia. So this is the reasoning and learning that it goes through and stores it in the system, then that gets applied in context. Here's another question on GE and Jack Welch. Again, unless you have it in the structured database, this notion of creating ontologies and semantic understanding. So what you're seeing here is basically a shift from a deterministic application to a probabilistic application, something that processes and says, I think there is a confidence level of 90% that GE was run by Jack Welch in this time. By the way, I used that deterministic versus probabilistic line with my teenager, and she said, yeah, Dad, that's very clear, and don't ever say that in front of my friends. So I have to come up with a better term for exactly what is the new class of business solution that Watson comes about. But let's take a look at how Watson works, right? The 3 simple things it does. I mean, very powerful from a technology point of view, but in terms of what it goes through, number 1, it understands natural language in human speech, okay? It understands how sentences are formed, how words are formed. It understands puns. It understands metaphors, similes. Very powerful capability that the IBM research team came up with over the 4-year period. Then, based on that understanding, it generates a hypothesis. It generates an answer panel that you saw in Jeopardy that says, I believe the first answer could be this or this is the probability around it. Okay? And once the user selects a particular pathway, it understands and learns from how that system is being used. All of this is built on the massively parallel probabilistic architecture. Once I got slammed on that deterministic to probabilistic, I never used the architecture term with my daughter. But that is a pretty cool piece of technology underneath it that powers Watson. So let's now take a look at a healthcare example and how this might come together. We here have a case of a 58-year-old woman and who comes in complaining of dizziness, anorexia, dry mouth, and it kind of gets entered into a medical record. And what the system does then, it starts extracting the natural language from it and says, okay, given that she's having difficulty swallowing, given that she's got fever and dry mouth, it seems like these could be the potential diagnosis models where it could be a case of influenza, it could be diabetes, UTI. So based on that first piece of information in the medical record, Watson's beginning to say these could be some potential conditions and this level of confidence. Okay, so it starts off with influenza first. Then you start adding on top of that the family history. Then you say this particular lady's family history has that her mother had cancer in the past, bladder cancer, they had Graves' disease in the family, and then Watson starts adding that and says, when I'm overlay that, it seems like to me that it looks more like diabetes. Then on top of it, you add another piece of information saying, here's the history, here's what's happened with her in the last 4 years. When she came in, these were the kinds of treatments that were given to her over the last few years. And then Watson looks at it and says, you know what, based on what I'm learning now from the symptoms, from the family history and the patient history, I don't think it's diabetes or influenza. Seems to me it could be UTI. Okay? And then last but not the least, we start adding on top of it medications. Okay, what are the medications that have been prescribed and what has been the impact of it? Then Watson looks at all the medical journals, looks at the patient records, and says, you know, based on all of this stuff and the test data, I believe with a fair degree of confidence that UTI is what she is going with, and that is the assistance that is provided at a pretty fast pace to the doctor or the nurse who is administering that patient. So pretty powerful stuff in how unstructured data and big data is pulled together in context of a physician's or a nurse's work stream and starts helping as, I call it like a car navigation system for doctors. Okay, it's a tool, it's an assistant that's helping you drive through. Watson's not making the decisions. Okay, Watson's helping, is being an assistant. It's just like you use a textbook. Now you've got a very fancy and a powerful textbook on a smartphone or an iPad or whatever context. So, you know, tremendous possibilities, tremendous excitement, but we are approaching this both with an equal measure of excitement and humility. It's one thing to have a Jeopardy playing machine that can beat the champions. It's another thing to come up with telco-grade business solutions that are domain-specific. And while we have a lot of talented people in IBM, one of the things that we do know is the best innovation is the one that comes about while partnering with your customers. So earlier in August, we announced a partnership with WellPoint, where we went about building the first pilot solution for WellPoint in healthcare. And let me give you kind of a quick story of what kinds of things they're looking for. This is around the notion of admissions and approval management and authorizations. So imagine I call into WellPoint. By the way, WellPoint is the nation's largest insurance company. They insure 34 million customers. 1 out of 9 Americans is covered by them, and they operate in 14 different states. So imagine I call into, you know, it's October, I call into my hospital or my clinic and I say, I want to come see you guys. I think I'm coming down with fever, it feels like flu, okay?